Okay, so again, today we're learning about electron configurations, and in order to understand electron configurations, we need to know a little bit about the periodic table, and we need to be familiar with the periodic table as a means of organizing elements. And so the first organizing principle of the periodic table is atomic number. And so hydrogen is atomic number 1, good. Helium is atomic number 2. Then you go lithium, and so on, right? And so as you go across rows and down the table or down columns, the numbers increase, the atomic numbers increase. And the atomic number gives you the number of,
I don't know.
not neutrons, but, okay, electrons is part of it, but the atomic number really refers to the number of protons. Now it is true that on the periodic table, all elements are considered neutrally charged. So if we've got, say, 4 protons for beryllium, then how many electrons do we have? 4. Because every single element is neutrally charged. So however many protons you've got, you also assume the same number of electrons. Okay. So that's your first organizing principle. But this table looks grid-like, and it's called the periodic table. So why is it arranged in a grid, and why is it called the periodic table, right? What in the world's going on? So it's called the periodic table because elements in the same column or the same group, for instance, this is group 1, this is group 2, group 3, etc., tend to share the same properties, the same chemical properties, okay? Hydrogen's a nonmetal, so it's a little different than the other alkali metals, but the alkali metals are all very similar. They're highly reactive metals, and the alkaline earth metals are also very similar, and they are also highly reactive metals, okay? So the alkaline metals are in this column because they share electronic properties. Chemical properties and electronic properties. The alkaline earth metals are in this column because they share chemical and electronic properties. And on it goes, okay? All the way over to the noble gases, and helium is actually a noble gas, but we'll talk in a little bit about why it's here. It's actually a noble gas because all of these noble gases fail to react with anything else in the periodic table. So they keep to themselves like the nobility, right? So they don't react with any of the other elements. All of the other elements can essentially react with any of the other elements. But the noble gases don't do that. They don't make chemical bonds, okay? They exist as monoatomic gases. That's their thing. And so what the early chemists noticed was that, and really the bulk of this work was done by a guy named Mendeleev, was that as we increase atomic number, we start to see patterns reemerging and properties reemerging. So you go from like 3 all the way over to 10, you get to neon. Then you come back 11 and you're back to the alkali metals, okay? Lithium and sodium are both alkali metals. And then you add 8 electrons, or 8 protons both, you get over to argon, right? Well, argon's just like neon. And then we come back, and we're back at the alkali metals. And really that goes for every single group in the periodic table, okay? And it shouldn't surprise, it was kind of amazing to me, but look, 3 metals that are both precious and valuable, obviously, are unstable: copper, silver, and gold, right? These are really stable metals. And we use copper for plumbing, we use silver and gold for jewelry and electronics, okay? And copper too, right? All of them are in the same family, okay? They have very similar properties. And so we're going to start to understand why that is. Why do these elements that are in the same groups have the same properties? In order to get there, we first have to be able to write electron configurations. And so over here on the right, and this is from ptable.com, it's really useful, I've highlighted argon, and I'll circle argon. And argon is atomic number 18, and I'll just write that down here, 18. And argon has something called an electron configuration, and that's represented right here. So this is a really useful periodic table, but I'll also draw it on the board, and I'll draw it to the right of argon so that you can see what's going on. So argon has this electron configuration, 1s2, 2s2, 3s2, or sorry, not 3s2, 2p6, 3s2, 3p6. And in case that gets cut off in the video, I'm going to write it again below. 1s2, 2s2, 2p6, 3s2, 3p6. And notice, I wasn't looking at the periodic table when I wrote that. So that looks like something to be like complicated, right? I don't have that memorized. But I just need to know that argon is right there, atomic number 18, and I can write that electron configuration no problem. And you're going to be able to do the same thing. So how? So again, the first organizing principle of the periodic table is atomic number, okay? 1, 2, 3, 4, 5, 6, etc., right? But the second organizing principle of the periodic table is periodicity. So these elements share a lot in common with each other. These elements share a lot in common with each other, and so on, right? And that's how the table is organized. And this highlighting gives us an additional layer of depth, okay? So these pink elements are in what is called the S block. So what I want you to do with your periodic table is go ahead and put a box around that and call that the S block, okay? Box this guy. Yeah, this is the S block. S block, okay? And it's a lowercase s. I always want to use capital letters because I like to capitalize titles, but no, lowercase s block. Okay, S block. And what you can do is, you can just draw helium in over here. Just draw it in. It's okay if you have 2 heliums on your periodic table. It's okay. You can draw helium in right there. And then these sort of like ripening lime green elements in the middle, these guys correspond to the D block. So you can put a box around these guys. These guys are the D block. D block.
What are the 2 that are sticky on?
Talk about that in a second. So over here, this teal group, these are called the P block. This is the P block. And these guys at the very bottom here are the F block, lowercase f block. Okay? F block.
Sounds like a prison.
And, well, they're not going anywhere, that's for sure.
Yeah.
So, S block, D block, P block, F block. Okay? And these guys in the middle, the way it works, Kevin, the periodic table actually should extend out with the F block inserted here, but that's just too complicated to represent on a single sheet of paper, so we leave it like it is, with these pulled out. But you'll notice, Kevin, lutetium and lawrencium are right here. They're actually part of the D block, okay? And lanthanum and actinum are part of the F block. All right? So that's how this thing gets pieced back together. These 2 guys are part of the D block.
Oh.
Okay? And don't let that little bit of business concern you, okay? We're not going to be worried about that. Honestly, I finished a chemistry major without having to worry about that, okay? Very few people use these elements for anything, all right? A lot of these intertransition metals and so forth, like they're not, anyway, they can be extraordinarily useful, right? But they're not the kinds of things that chemists typically talk about. Most chemists are focused on other things, okay? Other elements and so forth, and other chemistries. All right, so here we go. So we want to learn how to get here, right? So how do we get to argon being 1s2, 2s2, 2p6, 3s2, 3p6? How do we get there? What in the world is going on? Because I know everybody woke up this morning and said, my gosh, I wish I knew the electron configuration for argon, right? Like that's what we all woke up and said to each other, okay? We were like, golly, if I just knew how to write the electron configuration for argon, my life would be complete. Okay, well you came to the right place. So,
Read my mind.
what I'm going to do is, first off, I'm going to point to an element, and I'm going to name the element or point to it, and you're going to tell me which block it's in, okay? So, ruthenium.
D block.
Okay, Arsenic, P block. Okay, beryllium, S block. Okay, neodymium, F block. These are really interesting actually. Neodymium is used in rare earth magnets. I don't know as much about beryllium, but this guy right here, calcium, is very important for neural transmission and for bone strength. This guy over here, arsenic, will poison you if you eat too much of it, okay? So actually you do need to watch out with how much rice you eat, because there's arsenic in rice, not too much. And then, what was the other guy that I pointed at, ruthenium? I don't know anything about him, okay? But iron, of course, is the principal component of steel, right? So these elements are really cool, actually. So, okay, so helium, S block, okay. Carbon,
P block.
okay. Dysprosium, F block, okay. And then here, I won't give the game away, hassium. Okay, great. So now we're comfortable with these blocks, right? Okay. Now, here's how we get to argon being 1s2, 2s2, 2p6, 3s2, 3p6. Here's how we get there, right? It's easy, okay? You go to the element, and then you just count, right? What you do is you say to yourself the row and the number of elements in each block that precedes it, okay? So each unique situation. So each unique combination of row and block and how many elements there are preceding that. And that sounds complicated, but it's actually pretty easy to do. So here, first row, which block am I on?
1.
S, first row, S block, how many elements are there?
2.
Okay, 1s2, you say it. 1s2. Okay, now you keep going. We got to get all the way to argon, okay? So we go from 1 down to
2.
Okay, 2.
S2.
Good. 2s2. That's how many there are. 2, S block 2, right? Then we go 2 P, how many? 6. Okay. 2
P6.
P6. Very good. All right. Then you go down to 3 S2. Good. And 3 P6. Now let's go from the top. Okay, we're going to go all the way to argon. Ready, set, go. 1 S2. 2 S2. 2 P6. 3 S2. 3 P6. Okay? That, the scoop, it is. So we're going to get really good at this with most elements on the periodic table. I don't think we'll worry about F block stuff just because I don't think you need to be familiar with that until you get to AP Chem. But we're going to get pretty good through at least the first 3 rows of the periodic table, maybe the 4th and 5th as well. Okay? That's all for today. And next time, we'll talk about other elements. Thank you.
Yay.